When it's under your shoe, ice is about the slickest thing there is. But when it's on your car windshield, it sticks like glue. Ever wonder why that is? Turns out that it's because of something called interfacial cavitation. It sounds complicated, but it's actually pretty simple. And U of M researchers are using it to make a spray-on, ice-repellent coating that could make scraping your windshield a thing of the past. The new coating is made of common synthetic rubbers like polyurethane. It's more durable and less expensive than earlier ice-repellent coatings, and ice slides off with only the force of gravity or a light breeze.
To our knowledge, we've not found any other coating that can survive these kinds of challenges. Not only have we think, made some of the lowest ice adhesion materials, but we also think we've made some of the most durable ice-phobic materials that have ever been produced.
The new coating could help keep everything from airplanes to boats, wind turbines, freezers, and power lines ice-free. That could be a big deal for industries like transportation, shipping, and energy, where ice buildup is an expensive and dangerous problem. And like a lot of great ideas, it was discovered sort of by accident.
Instead of being an evolutionary next step in the field, it was like a revolutionary switch in how to make ice-phobic materials. You can make a silicone rubber as hard or as soft as you want. And before this, people had only thought it had a single ice adhesion strength. We sort of figured out that based on its physical properties, you can get a range of different ice adhesion strengths, even for the same material.
At this point, we've made well over 100 different coatings with all sorts of different materials. We've been able to develop coatings with ice adhesion strengths as low as 0.1 kilopascals. And to our knowledge, this is some of the lowest ice adhesion strengths that have ever been reported.
The rubbery coatings were great at shedding ice. Eventually, they figured out that it's because of, that's right, interfacial cavitation.
When you take a hard surface and you attach it to a soft surface, the hard surface doesn't want to move much because it's hard. Rubbers, like you think of like a rubber band, can expand a lot. And when you have those connected at an interface, what happens is what's called interfacial cavitation, where your rubber wants to deform, your ice doesn't want to deform. That creates a stress concentrator right at that interface, causes the ice to break free.
The first applications for the coatings should be up and running within a year, probably in frozen food shipping containers where sticking is often a problem. It'll probably take a few years to develop a coating that's tough enough for places like car windshields and airplanes. Once it's perfected, it could be used all over the world to make ice slide off our stuff as easily as it slips under our shoes.
The rice plant takes silica out of the ground and it puts it in the husk and it puts it in the stalk to reinforce them to make them stronger. Plants don't pick up heavy metals, so the silica